Hello everyone, today we are going to open copying box. A special thank you card for you. Copying itself. And other important stuff, I am going to explain them. So, let's continue. Obviously, we have copying itself here. And we have user manual. We strongly recommend you to read it carefully. We have filament holder feeds. We are going to explain it. Power cable and adapter. Seven-in-1 module. Blue PTFE tube. And 2 white PTFE tubes. A switch cable. This switch is very important to copying to work properly. An SD card reader, an SD card, fittings, bolt, nuts and nozzle. This is motor cable to make sure we have longer motor cable that not come off from copying. Copying feeds. These feeds are crucial to attach copying to the 3D printer. We have gifts from Turkey, a Turkish coffee and Turkish delight. And finally, we have 3 pieces. These are a bolt. This is nut. And we have 2 mill. This mill attached together thanks to this nut, and these mills, nuts and filament holders feeds all together creates a filament holder for you. So that's it. That's what's in the copying box. Let's continue. Now we are going to set up copying to the Ender-5 Plus. For Ender-5 Plus, we have special feeds for copying. As you can see, they are a little bit longer than usual. If these feeds are not included to box, you can download from our website from link below. Let's start with the removing PTFE tube from the 3D printer. To do that, we have to heat it to the hot end nozzle to 200 degrees Celsius, and then after that we are going to remove it. While heating the nozzle, we can attach feeds to the copying. Let me show you. Copying have 4 holes, as you can see here, and these holes for the feet. As you can see, this is right foot and it will be attached like this. For that, we are going to use metric for 20 bolts. As you can see, feed attachment is completed. To attach co-parent to the 3D printer, we are going to use this frame and M5 bolts and T-nuts. As you can see, M5 bolts will be attached to this hole and T-nut will be attached from the back of it, as you can see from here. Same process will be applied for the other foot, and then we are going to attach co-parent to this frame. Be aware that this step motor can be an object from co-parent to avoid from collision. If you can place the co-parent to like that in the middle of the frame, you will not be able to insert power cable because of this step motor. So we recommend you to place co-parent a little bit left of the 3D printer, just like that. As you can see, we are mounting co-parent a little bit left side of the frame. But before that, I'm going to remove the PTFE tube. to remove PTFE tube from the hot end, we have to press this fitting part and then we have to remove it like this. In this section, we are going to place this blue PTFE tube to hot end through the nozzle. But be aware that this blue PTFE tube has two sides, and one side is a little bit open from the other. As you can see, this side is a little bit open and this side is a little bit closed. I'm going to place this closed side to the hot end through nozzle, and this open side will be placed to the 7-in-1 module and exit of the 7-in-1 module. Be sure that you have placed PTFE tube through all the way the nozzle. After this section, we are going to cut PTFE tubes with the required length. Before that, we have to place the 7-in-1 module and core print. Let's continue with the core print assembly to the 3D printer. We are going to attach core print with the help of M5 Allen key. At this moment, we have to place the fittings to the core print. Now we can attach fittings to the 7-in-1 module to the inlet and the exit. The 7-in-1 module to the fittings assembly is completed. Now we are going to attach 7-in-1 module to blue PTFE. After that, we are going to cut PTFE tubes to correct lengths, because as you can see, this 3D printer can move on the x-axis as well as the y-axis, but as you can see, it doesn't move on y-axis, The reason for that is the core pin is placed a little bit too far on the left side, on my left side. So the right leg of the core pin is causing a friction between coupling. That's why the coupling cannot turn and rotate. That's why it cannot move on the y-axis. Now we are going to move core pin a little bit right side, and we are going to move away from the coupling. We are going to show the detailed photos of it, and then we are going to be able to go. Let's move core pin a little bit right side. Now, core pin is free from the coupling, and the 3D printer can move on the y-axis freely. The core pin is solid. Now we can cut the PTFE tube on the correct lengths. To give an example, I am going to use this 1 meter PTFE tube, and I am going to locate the head of the 3D printer as far as from the core pin. This will be the left side or the right side of the 3D printer. As you can see, the 7-in-1 module is very far away from the core pin, as well as on the right side and the right side. The point that I have to attend is, if I place this PTFE tube from the left side of the core pin, I have to be careful that there will be a place for the right side of the 7-in-1 module or left side of the 7-in-1 module. I'm going to place the left side of the 7-in-1 module, since I placed the PTFE tube on the left side of the core pin. The same thing appears for the right side. As you can see, if I move the head to the left side, I'm going to use the right side of the PTFE, the core pin, and I'm making sure the length of the PTFE tube is very well enough to reach farthest point between core pin PTFE and 7-in-1 module. Okay, be sure that you have enough length for the PTFE tube that will not cause a malfunction. Let's cut the PTFE tubes and meet at the end of the video. Now we have assembled the PTFE tubes, as you can see, and just as I mentioned, as you can see, there is bond on the blue PTFE tube on the left side. If I move this to right side, as you can see, the bond will be worse. To avoid this bond and this, the curve on the PTFE tube, we have to replace the part that I showed previously. But before that, we have to remove a bolt from the head. This bolt, as you can see, with using metric 2 Allen key. After removing that bolt, we are going to place this part to the back of the 7-in-1 module, like that. And as you can see, it will fit directly and it will not move in this way. After that, we are going to place this part to the front. be aware that these cables are not located between these parts, okay? After that, with using metric 3 10 bolts, we are going to use 4 of them and secure them, and after that we are going to use metric 3 20 bolts to secure the place that we just removed this bolt, okay? Now I am going to use metric 3 Allen key. Now, as you can see, we have finished the assembly of this part. As you can see, the 7-in-1 module is located on straight way and straight path. As you can see, it will not move or bond on left side or right side. Now we can attach E-step motor cable to the core pint. To do that, we have to remove E-step motor cable from the 3D printer. You will find a cable right below this motor, and the E code will show. We are going to remove this cable. As you can see, there is E writing, and then we are going to place it to the end of the core pint. Either you can use this cable, the motor cable, or you can use this cable only. In this situation for Ender-5 Plus, you should not use this cable, but the other printers can require this cable. Okay? Be aware that this cable is not too tight when you attach it to the core print. Okay? We recommend you to do this step while the 3D printer is closed. If the 3D printer is open when you are removing the cable and stuck it into the core print again, you may cause a damage on the 3D printer. So just close the 3D printer and remove the cable and stick it into the core print again. Now we can place the limit switch cable to the Ender-5 Plus. Now we are going to attach switch holder to the Ender-5 Plus. In this situation, either you can place it on the x-axis on the left side, which is approximately 300 millimeter, and also you can place it on the 0. But Ender-5 Plus has limit switch on the left side, which is approximately, as I said, 300 millimeters. So I'm going to select the right side, which is the 0, as a location on the x-axis, and I'm going to place the switch on the 0 as a location on the x-axis, okay? But remember that I have to write 0 to coherent application on the x-axis, the limit switch location, so that the coherent is going to move the head of the 3D printer on the right side, not the left side, okay? This is very crucial to do that, okay? Let's assemble this limit switch to the 0 on the x-axis. I'm going to place it like this, okay, to the bottom of this line, okay. I'm going to use metric 5 Allen key to secure it. As you can see, I attached this part to the very end of the x-axis, which is I place it to this place, and this cannot go to the right side far more, okay, because there's a steel part. After I secure the bolt, now we can be sure that I will be open the 3D printer and I will do the auto home sequence for the 3D printer, and then I'm going to set a 0 location on the x-axis, and I'm going to confirm that the head of the 3D printer hits the switch, okay? But before that, we can attach this cable, the limit switch cable, to the coherent. Just like that. Now we can open the 3D printer and we can do auto home. As you can see, homing on the x-axis is end of the x-axis for the Ender-5 Plus, okay? Now auto home is finished. The 3D printer says that the head of the 3D printer is located at the 180 millimeters on the x-axis. Now I'm going to write 0 as a location and I'm going to click OK. Let's observe this. And yes, it hits the limit switch, so that we can confirm that we place the limit switch to the right place, okay? As a reminder, do not forget to write 0 on the coprint application. Now we can power up our coprint by using this power unit and the power cable. For this process, I'm going to need help of my friend to plug the cable. Let's just give it like this. As you can see, coprint is alive. It's calibrated itself. Now everything is set up. All we need to do is to calibrate extruder for the Ender-5 Plus. Because of that, since we changed the cable of the extruder from 3D printer to the coprint, we have to change the air step value, but the Ender-5 Plus does not provide any settings on itself. So we can use a program called Repetier Host, and we can connect our computer to the 3D printer, and then we can change the extruder calibration, okay? For the specifics, let's continue on the computer. Now I have connected my computer to the 3D printer. To extrude a filament, of course, we are going to need a filament. I have filament here, but I am going to show how to use a filament holder for coprint. As you remember, we have 2 mills and 1 bolt, 1 nut, and as you can see, if I secure it like this and this one to this, like that, after that I can place this part and this part so that I can place my filament on this shaft, okay? To place it, of course, I'm going to remove one side. And then I'm going to place my filament through the shaft. And then I'm going to place this part back in. Now I can put it on the ground or anywhere I want. I'm going to insert the filament to the first extruder of the coprint. Now I will remove this PTFE tube from here to measure this length, okay? I'm going to set a 0 point. It's seamless to the fitting. When I extrude 100 mm, I will record it and then I will do an calculation and then I am going to extract it again. Okay? Let's continue with extraction, but remember that the hot end, the nozzle must be heated to the 200 degrees Celsius. Now I have connected my computer to the 3D printer. We are using Repetier host program to extrude and change the A step value from computer. Let's extrude 100 mm of filament after heating the nozzle to 200 degrees Celsius. I previously heated the nozzle to 200 degrees Celsius, so I can extrude 100 mm of filament right now. Let's observe it. It is approximately 68 millimeters of filament length. Now we are going to do a calculation, which is if my A step value is this and it gives me 68 millimeters of filament, which value I have to write as an A step so that I can reach 100 millimeters of filament. To do that, I am going to use Alt and E keys on my computer, and I can observe E axis resolution. It says 93.4 step per millimeter. So that, as I said before, I'm going to open a calculator from my computer. If 93.4 step per millimeter gives me 68 millimeters of filament, what value or which value will give me 100 millimeters of filament? The equation is very simple. 93.4 multiplied by 100 and divided by 68. The result is 137.35. Now I am going to write this value to the Repetier host program. And I am going to apply it. Now I can extrude 100 millimeters of filament again and I can observe the result. As you can see, it has more length. Let's check it. It is 96 millimeters. So that we are going to redo this calculation until we can reach 100 millimeters of length of extrusion. As a result, we have reached 100 millimeters of extraction when we send a command 100 millimeters of extrusion. As a result, our step per millimeter value is 161.58 step per millimeter for this specific Ender-5 Plus. So, since we reach and we done the extruder calibration, we can easily take multicolor print with Ender-5 Plus. Thank you for watching. See you on another video.